Hello again, year 11. Today we are going to be looking at the topic of quadratics, and we are going to be looking at a lot of work we have done previously, but seeing how all of this ties together in a sketch of the graph. Most importantly, how completing the square tells us where the turning point of the quadratic function is. So let's get straight into it today. And if at any point I go through a topic of the maths where you're a little bit less confident with it, I would suggest you do get in touch with me in the Ask the Teacher channel. So for example, I am going to be assuming that you can solve a quadratic equation. I will be briefly going through the process of completing the square again, but I've recently made a video for my year 10s, so I will link that in the description below, particularly if you are interested in the process of completing the square. So if you've managed to print out a sheet today, that's great. I would recommend printing it in a little bit of colour, or if you can annotate your sheet with a bit of colour, that would be a really good idea. So just to remind you, the process of completing the square is where we rewrite a quadratic in the form x plus p all squared plus q. And the important thing that we spotted when we did the work on complete the square is that when you're generating that rewritten form, the value of p is always half the coefficient of x, so always half the value of b in your quadratic. So what are we going to be trying to do today? We are going to be trying to sketch a graph just from the equation. So no table of values, no super neat tidy axes are required. We are just picking out some key points. And we are picking out 4 key points that we will use to plot the graph. We've done a little bit of work on sketching graphs before when we met quadratic inequalities. So certainly the concept of the green and the blue points is something that isn't new. So the green point is the intercept on the y-axis, and that we can get from our equation by looking at the value of c. The 2 blue points, we mentioned this 2 lessons ago, is where the graph crosses the x-axis, and those are the solutions to the quadratic equation. Most of the quadratic equations we look at today will factorize. And then the new part is the red point, and we can work out the coordinate of the turning point by completing the square, and then we need to do a little bit of analysis of what that looks like and relate it to the topic of transforming graphs, which we did in the autumn term. So a lot of pulling knowledge from different areas of maths and pulling it all together. Let's look at an example and see how this works. So let's look at this first example. It says find the key points for each quadratic function and sketch the graph. So we need to work out the 4 points that we are going to use: the y-intercept, the x-intercepts, the turning point, just from this equation, and then sketch the graph using those 4 points. So I'm going to do them in that order because that's easiest. The y-intercept is just this number here, -12. I'm going to write down some key points here just at the side. So I'll call that and label that y. To find the x-intercept, I need to solve the quadratic equation. So I'm going to put it equal to 0 and solve it. And like I say, factorization will be the way that I'm going to be getting you to solve most of the equations today. So x at the front of each. What numbers multiply to make 12? Well, it's 6 and 2, because 6 and 2 have a difference of 4. The signs are different. It's -6 and +2. So either x take away 6 equals 0. So that gives me the answer x is 6. Or x plus 2 equals 0. That gives me the answer x is -2. So those are going to be my x-intercepts. So finally, we're getting this fourth point, and this fourth point is coming from completing the square. And completing the square is rewriting this algebraic expression. So, remember, we have a value that goes in the bracket here, and then a number to make sure that this expression is equivalent to this. So how do we do this? Well, we need half the coefficient of x. So we need half of -4, which is -2. I normally remind myself what I've got at this point. So x take away 2 squared is the same as x squared minus 4x. That's doing outers and inners. And lasts is +4. So this is what I have, but I need it to be -12 on the end, and I have +4. So I need to subtract 16. So you might be thinking, well, why does this expression tell me the coordinate of the turning point? And this all comes back to the topic of transforming graphs. If I have a function y equals x squared, and I adapt that function, you might remember if we add a number on the end, that translates the graph up or down. So this -16 is pulling this graph down 16 places. Similarly, this expression here is the scenario where something is happening to the function before the operation. And this was a translation along the x-axis, but this kind of did the opposite to what you would have expected. So because this is -2, that will push the turning point 2 to the right. So I know the coordinate of my turning point should be 2, -16. So I'll just pop that down there as well. So I've got the 4 values I was after, and now I'm going to do a sketch of the graph. Now when you do a sketch of the graph, yours is going to be tidier than mine, because I would like you to use a ruler and a pencil for your axes. But everything else can then be an approximate sketch. Okay? And what I mean by that is I know it crosses the x-axis at 6 and -2. So if I put 6 there, proportionately, maybe -2 is about there. So try and keep the scale along your x-axis consistent, and similarly along your y-axis. I need to use -12, so I'm going to drop -12 about there. Obviously the scale for my x-axis and my y-axis are different. And then the other value that I'm going to need is my turning point, which is 2 and -16, which I'll pop there. Now I'm going to plot these as points. So that one and that one, where it crosses the x-axis. That one is where it crosses the y-axis. And that one needs to be my turning point. And the idea is you can now sketch in your quadratic U shape. Should be symmetrical. If it isn't symmetrical, it's because I've not spaced these out particularly well. Like I say, you will do a better job at sketching it than me. Okay, but that is the aim. Get your 4 values, sketch your graph. Let's have a look at 2 further examples. So, same idea again, y-intercept, x-intercept, and turning point. So, we can see the y-intercept on this one is 5. Going to factorise to get my x-intercepts. 5 and 1 multiplied to make 5, and they add to make 6. So either x plus 5 equals 0 or x plus 1 equals 0. So I get two answers of -5 and -1. So those are going to be my x-intercepts. Now let's complete the square on this. So half the value of 6 is +3. What is x plus 3 squared? Well, that is x squared plus 6x plus 9. So I've got a little bit too much. I need to get it back to 5. I am subtracting 4. So what does that tell me about my turning point? Remember, it's the opposite of that one. So it's -3, -4. So let's have a go at sketching this one. See if I can do a better job than the last. So I'm crossing the x-axis at -1 and -5. I'm crossing the y-axis at 5. And my turning point is at -3 and -4. Let's plot those as points. X-intercepts, y-intercept, turning point. Draw in the curve. So let's look at our last example, and maybe one or two of you might be able to quickly spot why this one is going to be a little bit more challenging. So let's have a look first of all at the y-intercept. So we can see that the y-intercept is -28. Let's factorise to find the x-intercepts. So what numbers multiply to make 28? Looks to me like this one is going to be 7 and 4, because 7 and 4 have a difference of 3. The signs are different. It is -7 and +4. So either x take away 7 equals 0, or x plus 4 equals 0. So my two answers are x equals 7 and x equals -4. I'll just jot those over there. And then completing the square for the turning point. Right, have you spotted it now? The coefficient of b is an odd number, which means the value here is going to look a little bit odd as well. I'll let you decide whether you want to use decimals or fractions. I think most of you would prefer me to use decimals, so I will do. I normally would use fractions, but entirely up to you. Let's see what x minus 1.5 squared actually is. So if I multiply that out with FOIL, I'd get the x squared, I'd get the -3x, but the lasts would multiply to make positive 2.25. So how am I going to get back to -28? Well, I'll need to subtract -30.25. So my turning point, remember, opposite of this one is going to be 1.5 minus 30.25. So let's have a look at the sketch. Crossing the x-axis at 7. It's crossing the x-axis at -4. It's crossing the y-axis at -28. And then we have this wonderful turning point at 1.5 negative 30.25. So let's plot those points. X-intercepts, Y-intercept, turning point. Let's try the other way. And that is a sketch of your final function. So there are some questions for you to try. I think I've asked you to do 6 in total. See how much time you have. You'll find there's a little bit of a problem with the final function that I've given you on that sheet. If you can't print that sheet, don't worry, just set it out in your book instead. As always, don't forget to check your answers. The answers are back on my PowerPoint. And if you have any problems, you may ask in the Ask the Teacher channel.